Hey, Honor Stats. This is start of chapter 8, which is dealing with estimation. The first thing we're going to do in chapter 8.1 is we're going to estimate mu. And you got to remember, mu is the population mean. All right. When sigma, which is the population standard deviation, is known, it's given. So things that we're going to do, we're going to explain the meanings of a confidence level, an error of estimate, and a critical value. We're going to find the critical value corresponding to a given confidence level. We're going to compute confidence intervals for mu when sigma is given, and we're going to interpret these results. And the last thing is we're going to compute the actual sample size when estimating a population mean. So reiteration, please understand that we talked about confidence level, our error of estimate, and a critical value. We found our critical value corresponding to a confidence level, not only the ones you're supposed to memorize, but I did remember 92%. We computed an entire confidence interval. All right, we interpret the results. And the final thing we just did right there is we found the sample size used for estimating our mean mu. Okay, guys, that's chapter 8.1. So the first thing you need to know, when we're estimating the mu, when sigma is given, well, we obviously don't have the mu. That's what we're trying to find. Our point estimate that we're going to use is x bar. Remember, x bar is our sample mean. So we're going to use our sample mean to find our population mean. Now, the next couple slides, I'm going to explain this value called a critical value, Z sub C, okay? You're going to have to, at times, find it yourself, but for a majority of the questions, it's memorization, okay? So the critical value is basically the Z-score that you are going to use to help you find our population mean. So let me show you in this example how we're going to find our critical Z, Z sub C. And this is for a 99% confidence interval. As you can see, we draw the normal curve. We're looking for a positive and negative Z. So we're looking for an interval. So being that it's a 99% confidence, the 99% goes in the middle. As you can see, we wrote it as a decimal. Well, if you subtract from 100, that means there's 1% left over. Well, that 1% has to be evenly divided amongst the two sides. So we're dealing with 0.5% and over here 0.5%. As you can see, we change it to a decimal. So when you look up this positive Z-score, you have to take what's to the left of it, looking up the positive. So when you add 0.99 and 0.005, you get 0.9950. And you're going to look this up in the body of your Z-score table. And you're going to get the corresponding Z-score for it. So let's take a look at that. So our Z sub C for a 99% confidence interval is 2.58. You never ever have to look up one ever again for 99%. It's always 2.58. And now our margin of error. Our margin of error is denoted by the letter E. It's going to help us with our interval. Our confidence interval for mu is going to be x bar. Remember, that's our point estimator, our sample mean. And we're going to add our E to that, our error, margin of error, and x bar, you're going to subtract the margin of error. This is what is going to turn into your confidence interval. Let's take a look at the E again. The Z of C, this is what we just found. Remember, the 99% relates to a 2.58. That's our critical value. Sigma, remember, this whole section is we're finding the population mean when sigma, the population standard deviation, is given to you. And then obviously n has to be given to you in the problem because we need to know our sample size. So this one page shows us everything. Please understand, we would like to have a value of n that's larger or equal to 30, because we know that the central limit theorem takes over. If not, they need to tell us that our x distribution is approximately normal. Here's the confidence interval that I just stated for you. We are taking our x bar and adding and subtracting our margin of error. This is the formula for margin of error. It is our critical value Z of C, our sigma, which is going to be given, and our n, which is also going to be given. So let's take a look at an example. Julia enjoys jogging. She has been jogging over a period of several years, during which time her physical condition has remained constantly good. Usually she jogs 2 miles per day. The standard deviation of her time, sigma, is 1.80 minutes. During the past year, Julia has recorded her time to run 2 miles. She has a random sample of 90 of these times, so now we know what n is. For these 90 times, the mean was 15.60 minutes. Let mu be the mean jogging for the entire distribution of Julia's 2-mile running times taken over the past year. Find a 95% confidence interval for mu. Okay, so let's understand of all the pieces that we have. We have sigma, which is 1.80. Remember, this whole entire section is we're trying to find out mu when sigma is given. We know that n is 90, and we know that x bar is 15.60. All right, so those are important pieces for any type of confidence interval problems when sigma is given. Okay, being that n is 90, which is greater than or equal to 30, the central limit theorem takes over and is applied, and therefore our x distribution and our x bar distribution is normal. Now let's talk about our 95%. Our critical value for 95% is 1.96 for this guy. 1.96. So 95% is 1.96 our critical value. I was thinking of 98, which is 2.33. Okay, so here we go. The first thing you're going to find is our critical value. It is found by taking our Z sub C and multiplying it by the square root of sigma, multiplying. Boy, I'm just off today. Sorry about that, guys. multiplying it by sigma over the square root of n. So our z sub c is 1.96. Our sigma is 1.80. And our n is 90. So we're going to plug all this into our calculator, and we're going to go to 2 decimal places. So plugging it in, we get 0.371, so 0.37. And now let's set up our interval. Our interval for mu is going to be our x bar plus the e and our x bar minus e. X bar is 15.60, take away the 0.37, and 15.60 adding the 0.37. So therefore, our final interval is going to be between 15.23 and 15.97. And putting it into words, when we interpret it, what's her name? Julia. So, I am 95% confident that the true population mean of Julia's 2-mile running times is between 15.23 minutes and 15.97 minutes. So hopefully you take those words as I said them and you write them down, because that is the explanation of this particular interval. Okay, at this time I want to digress for a second and remember the confidence interval. So we're going to make up one. Let's go 92%. It wasn't on your chart. So what we were going to do is we're going to find our critical value for 92%. And this is how you do it. You draw a normal curve. You make an interval, and the 92% is in between. When you subtract from 100, you get 8. That means there's 4% over here and 4% over here. We always look for the positive z. Why? Because we're going to add those values, and a z-score is always positive. So 92 plus 4 is 96%. We're going to turn that into a decimal, which is 9600. And we're going to look in the body of our chart for that particular value. So our z sub c for 92% is 1.75. And you can actually commit that to memory now if you want to add it to that list. Okay, so the ones that you definitely need to know. You need to know 90%. You should know 95%, 98%, and 99%. This one is 1.645. This one is 1.96. This one is 2.33. And this guy is 2.58. These 4 are by far the most common. But what I did here, you can find any value for z sub c that you want for any confidence interval by doing this work. So let's take a moment and look at some very common critical values. 99%, the one that we found, this is your memorization, 2.58. 98%, your memorization is 2.33. For a 95%, your memorization is 1.96. For 90%, it is 1.645. 85% is 1.44. 80% is 1.28. These other two are not really used, but if you memorize them, it won't hurt you. Okay? So remember, these are your z sub c's, which are part of finding our margin of error, which in turn will give us our confidence interval. So these guys you have to memorize. All right, at the end of this, I'll do one more. I'll choose a weird percentage, and we will do it so that you understand how to find a critical value. It's not this one, it's 1.96. So let's go back. I showed you here in the critical z-scores. Let's find one that's not here, okay? And now the last part. What about our sample size? We need to choose our appropriate sample size when given a problem. So our formula is going to look like this. N, which is sample size. Z of C, because I'm going to give you a confidence interval, so it's going to be one of those memorizations. Sigma, which is going to be given, but we're going to give you the margin of error. So we want to know how many people or how many whatevers that we need to survey if we want to be so many % confident within this particular confidence error. This is what I should have said before. If n is not a whole number, increase n to the next higher whole number. So you don't round like. So the example here looks like this. A wildlife study is designed to find the mean weight of salmon caught by an Alaskan fish company. A preliminary study of a sample size of 50 salmon showed that the sigma of 2.15 pounds. How large of a sample, so that means we're looking for n, to be 99% confident we're within 0.2 pounds, okay, of the true mean weight. So let's pull our pieces off. So our z sub c for 99% is the 2.58. Sigma was given to us to be the 2.15. And we have to have an E of 0.20. Okay? And we know the N is 50. Or, sorry, random sample of the 50. I don't know why I said the N is 50. That's what we're looking for. Okay? So here we go. N is equal to square. Z of C is the 2.58. The sigma is the 2.15. And the E is 0.20. So we plug this all into our calculator. You take 2.58 times 2.15, hit enter. Divide it by 0.2, hit enter. And don't forget to square. When you square, you get 769.23. Okay? Always, always, always. And let's see if we can find it here. Normally round. You have to go to the next highest number, which is 770. So that's how many salmon that should be caught. Okay? Don't round accordingly. A round up. So if it's 769.001, it's still 770. If it's 769.9, it's still 770. All right? And that's how you find your sample size. So here's our z-score table. We're looking at the body, and we're looking for 9950, sorry. So here's a 9945, 46, 48, 49, 9951. So even though this one is smack dead in the middle, the book always, for just this one, and this is the weirdest one, is they choose the largest one. Interpolation, it's actually closer. You don't know that, but it is actually closer. So 2.58 is the critical value that you're going to memorize for 99%. So we're looking for 9600. So 958295. Look at this guy right here. That's as close as you can get. 0.9599. So the z-score is 1.75.